All right. So, everybody got your quiz? I haven't posted a key yet, so I guess if you just have questions on it, just bring it up to me after class. I'll answer it for you, no problem. We're going to finish chapter 9. Just have a couple of pages here. So, don't forget the Mastering Chemistry assignment due on Friday night. Exam 3 is on Monday. Chapter 7 through 9, maybe a little bit from the end of chapter 6. Not a big deal, but the study guide is in D2L, so print that out if you have not yet. Our lab projects are progressing nicely and starting to draw down. Presentations for the Wednesday people are next Wednesday. For the Monday people are a week from Monday. So the Monday people still have one more week of experimentation or lab work to do. Make sure to look at both places when you're getting your presentation and your report. Okay? The lab project web page, that's the same place, when you go to all your experiments in that first link in D2L. I'm going to show this to you because there's always somebody that says, I didn't know there were two places to find stuff. So when you go to your experiments, right, you've seen this page here, lab project. Definitely read through all of that again because there's information about the report and the presentation. Also, for the report, okay, especially the formal report, read very carefully through this section on laboratory reports because you will need to have all components of the report this time. Okay? Sometimes in the past you only had to do parts of it. Okay, well you got to do the whole thing. It needs an abstract. It needs an introduction. Experiment procedure. You need to write out the procedure. Results. Discussion. Okay. Conclusion. References. Okay. Don't forget, any data that is not your data has to be cited for some source where you got that data from. So literally, if you're typing a number in your report, and that isn't a number that came from your data or just came from your brain, you need to cite where that came from. Okay? Or if there's some idea or some kind of general thing, it needs to be cited, and that's very important. And you do that like this, right? You put a little subscript after what it is you want to cite, and then at the end you have a numerical list, okay, that's going in the order that they were cited. Okay? Use the format shown here for doing those citations. Okay? That's very important especially for science, but you do research papers in all your classes. It's very important that you attribute data to its proper source. Otherwise, it's considered plagiarism, right? So, be very careful reading through those, especially for your report, but also the extra little guidelines that I made. Okay, that's in handouts here, handouts. I handed a hard copy of this to you the first week of lab, but it's also right here because we know what happens to hard copies. Okay. This page has very specific instructions for how to write an introduction. This introduction needs to be beefier than introductions before. It essentially needs to get your classmates up to speed with the level of understanding that you have with your project. Okay? That's what you need to think of it as. Okay? So be careful when you're choosing your sources. There's a specific number of sources that I need and so on. So read through that carefully. I will be assessing it based on this. Okay? When you are preparing your presentation, these are the presentation evaluation criteria. Okay? I will be grading you on this, and you will be grading each other. You'll be doing peer reviews of your presentations, and the score will be a combination of those. So definitely look through all this. Make sure you have addressed every single one of these things in your presentation. Okay? It's actually interesting considering this is a chemistry class, but what I often find lacking is this one. Chemical explanation. You need to somehow bring it back to the chemistry, optimally the chemistry that we've learned in this class. Okay? But, you know, you need to have some sort of, here, and here too, chemical formulas, okay, of the substances you're using. Structures, if they're molecules. Okay? You can find structures of molecules everywhere. Okay? That's got to be there. If there's a chemical reaction happening, you need a balanced chemical equation. Okay? Sounds simple enough for a chemistry class, but you'd be surprised how many people have no structures, no chemical equations in their presentation. That's one of the more important things, I think, for a chemistry class anyway. Okay? So read through this. Read through this very carefully, again, because this is what you will be graded on. Okay? And I will not be kind if there are no references, if there are, you know, no formulas, structures, or equations. Okay? So, also in this same handout, the criteria that you'll be graded on for the formal report itself. Okay? So, go through this as, you can think of this sort of as a checklist as you're preparing your formal report. Okay? Making sure that you've very thoroughly addressed the things that it says in there. Okay? So, that's the lab project webpage and the project guidelines in the handout section. Everybody understands that those are two different things, right? Okay, good. Evaluation criteria. The formal report, this has changed a little bit because we missed that one Monday. The formal report for everybody will be due on final exam day, December 18. Okay? That's 2 weeks from today. That can't be right. Yeah, it is. Yikes. Okay. So, yeah. So I will have a Dropbox open for the formal report and submit that before you come to class for the final exam. Right? Again, refer to that handout for the information about the introduction, refer to the project webpage, refer to the lab reports webpage. I'm going to be expecting all of those things. Okay? I've returned another lab report to your Dropbox, the one that had the procedure that you wrote out, and most of you did fine. A couple of you I caught using commands or using present tense or using first person. Okay? Procedures, especially, are always, in science anyway, written in past tense. Okay? And wherever possible, they're written in third person. So you're not saying, we did this, we did that. Okay? In science, we try to be selfless and focus on the experiment and the stuff that's happening, not the experimenter. Right? So this substance was measured into a prepared, you know, like that. Use past tense. Try not to mention yourself. You know, it's not a sin to mention yourself, especially in like the discussion, especially if it's some sort of judgment that you made. But mentioning yourself in a scientific lab report is used as a point of emphasis. Okay? So if you put we or something like that, okay, that's a specific point of emphasis. That's a judgment that you made or something like that. Okay? But there usually are not judgments that are made in the procedure. So procedure is always past tense. Procedure does not mention the experimenter. That make sense? Okay. So that's your fair warning. I'm going to nail you on that if you get that wrong in the formal report. Okay, that's important. And that's, you know, that is important. That's a piece of mechanics about scientific writing that you should be aware of. What's most important, though, I think, and you can tell from the points in the point layout in the formal report, is that you clearly is that you had a clear research question, you had a clear procedure that you went through that addressed that question. Right? You controlled for variables. You were, you were rigorous and methodical in your experimentation, and you have a fairly significant. This one should have a really significant discussion to it. Okay? And the discussion is different just from the procedure. I nailed a couple of you on the reports for just sort of saying the procedure again in the discussion. That's not what it is. The discussion is essentially a persuasive essay where where you had some sort of objective or question that you were answering. You're saying the discussion is the response to that, essentially, using your data, what you found, okay, and how that question is answered or fulfilled. Okay? So citing your sources, repeating key sets of data that are written. You may have had some numbers in your, all your numbers and stuff are going to be in your data section, but repeat key sets of data that get your point across, right? The point is, think of it as a persuasive essay. Be as clear as possible in showing that you met the objectives or answered the question in some way or another. Okay? So that's what is actually most important about something like this. Okay. So, anybody have any questions?
We don't have a lab that final exam day, right?
No, we do not. No lab on Wednesday. The final exam itself is 2 hours, so we're going to start at 1:30 and we'll go till 3:30 in here, but then it'll be done.
And then I haven't looked at the presentation requirements or guidelines, but are we supposed to pass out a copy of our report to everybody? So we can go through it as we do the presentation?
No. The presentation is just the presentation.
Oh, okay.
Yeah. So. Yeah.
And the presentation is just in the lab with everybody else that's in that lab.
Yep. Okay. Just for the lab section. Mm-hmm. Yes.
Do we have to cite stuff in the presentation?
It would not be a bad idea. You should have your last slide should be references. Okay. If you had specific data, especially that you took from references, use a superscript number within your slides to cite that, essentially like you would in your report. A lot of you based your experiment off of a procedure somewhere. You should say something like that. Okay? You could just say on your slide or in your report, this was based on a previous procedure, and then cite what that procedure was. Okay? But then you should be describing what your actual procedure was, too. Okay? Other questions? Try to talk for 10 to 15 minutes. Okay? That seems like a lot, but that is not a lot. I stand up here and talk to you guys for 75 minutes twice a week, so it's honestly not a lot of time. Okay? That's pretty much enough time to get through the things on the requirements for the presentation. Okay? And that's about it. But you should be getting your presentation together in advance and rehearsing it to make sure that your timing is appropriate. More often than not, I've had to hurry people along, okay, to make sure they get it in. But you also don't want to deliver a hurried presentation. That's not fun to listen to either. So practice your presentation. Make sure your timing is about right. 10 to 15 minutes usually is about right. We'll ask questions and discuss for 5 minutes or so after that.
If we have a short experiment, can we conduct it?
Mm-hmm. Absolutely. Yep. It's an excellent visual aid. I forgot to mention, I think I encouraged everybody to take lots of pictures of your experimental setups. Put lots of pictures in your presentation. Nobody likes to look at big walls of text in a PowerPoint. Okay? You've probably had classes where the instructor has had big walls of text in a PowerPoint. It's no fun. Okay? Have lots of pictures. Have just the essentials on the slide. That's just good presentation sense, right? But fill in, as you go. A lot of you did just really outstanding, really cool experiments, and a lot of them looked really cool too. So make sure to show what you did so that your classmates get a really good idea of what happened. Any other questions?